tomorrow tutorial. This is the tutorial sheet for tomorrow. Tutorial for tomorrow. All right, guys. Okay. Now, I want to recap what we did last week. Mainly, how many? 1, 2, 3. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2 people missing today. 2 people. All right. So I want to recap what we did last week, okay, before I continue. Now, last week we talked about bivariate. We talked about bivariate extreme value theory, right? And I gave you examples of bivariate extreme values, right? Like in flooding, you have extreme rainfall and extreme wind speed. And I gave you a second example where in droughts you have extreme rainfall, extremely small rainfall, and extremely high temperature. And in forest fire, you have extremely high temperature and extremely high wind speed, and so on. And these are some pictures that I showed you last week. I will not show them again. Okay, but then I asked the question how to define a bivariate extreme value, and I said that the common definition is this one here. Although this may not occur, this may not be an actual observation in practice. However, this is the most common definition of bivariate extreme value, right? So this is an example where the bivariate extreme value does not occur. It's not a real data value, okay? And then I talked about finding the joint CDF of this pair here, and after some calculations, it turns out that the joint CDF is equal to this one here, okay? And then I asked the question, what is the limit? What is the limit of this as n approaches infinity? Okay, all right. So then the answer for that is the following: that if the limit exists and you call it g of x comma y, then the possible forms for g of x comma y can be uncountably infinite. Okay. And then I showed you how to. There is a four-step procedure that you can use to determine the g if it exists. Right. The first step is to find the marginal CDFs. Second step is to find the max domain of attractions. The third step is to find A and B and C and Dn. And the fourth and the final step is to find the limit of this as n approaches infinity. Now I did 2 examples on it. I will try to do more examples maybe tomorrow. I will try to do more examples tomorrow if I have time, or even later today if I have time. But what I'm going to do is, I said earlier on last week that if if the limit for G exists, then the possible forms are uncountably infinite. But there is a good news, is that the good news is that the possible forms can be represented in a certain way, right? So that's what I'm going to talk about today, right? So what I'm going to talk about is representations for possible forms for G, right? Okay, I'm going to consider a few cases. Case 1, if fx and fy, remember fx and fy are the marginals of the f, which is the data, the joint CDF of the data, right? So if they both belong to the Gumbel max domain of attraction, then g of x comma y, the possible forms for g of x comma y can be represented like this. Okay, so you follow what I'm saying, that if fx and fy belong to the Gumbel max domain of attraction, then the possible forms for G, which are still uncountably infinite, I mean the possible forms are uncountably infinite, but they can be, the uncountably infinite forms for G can be represented in this way, where f1 and f2 are non-negative functions that integrate to 1 between 0 and 1. Okay? Is that clear, guys? Okay, we will do some examples later on. Don't be scared. Okay. If you have any questions, feel free to ask me, guys, please. I mean, I'm trying to help you as much as I can, guys. Okay. Alright, that's number one. Number two is the following. So this is the first representation for G. The second representation for G is as follows. All right. So this is the second representation. It also applies in the case that the both margins, that the x and the y margins of F belong to the complex domain of attraction. In this case, G can be represented in this form, where K is a function on the real line that satisfies these five conditions, right? So this representation here and the representation over here, I mean this representation and the representation over there, they are both equivalent to each other, right? They are both equivalent because they both apply in the case that the margins, the marginals belong to the complex domain of attraction. Right? Okay. All right, guys. So that's number two. Any questions so far, guys? Yes, sir. Okay. Next one, number 3. Number 3 is the following. Okay, number 3. Oh, shit. Sorry. Number 3. Okay. So here, we are supposing that the two marginals belong to the Frosch-Max domain of attraction. All right. In this case, the g of x comma y can be represented like this. Right, can be represented like this, where a is a function from 0 to 1 to 0 to 1 satisfies the following. Okay, let me write them down. The first condition is that a of 0 is equal to 1, a of 1 is equal to 1. The next condition is that for W, and the final condition is that A is convex. Okay, you know what a convex function is. How do you check? I mean, so these are 4 conditions that A must satisfy. That A of 0 is 1, A of 1 is 1, that A of W must be between, oh, what did I write? Should be 1. Okay, A of W must be between these two for all W. And finally, the function A must be a convex function, right? Okay. Alright, so do you know what a convex function is? You haven't done it? Ah, come on, guys. What is a convex function? You must have done it like ages ago. Like, you maybe forgot. Huh? No? Yeah, but how do you check something is a convex function? Like, if you want to know, like, a function is convex, how do you check? Convex is it looks something like this. A function looking like this is a convex function. But how do you like, if you want to check, say, a function is convex, how do you check? Come on, guys. You don't know? Anyway, let me write it down. Right. You say that a function is convex if its second derivative is positive for all x, then it's a convex function. Okay. It's easy to check. Like all you need to do is find the second derivative and show that it's positive. Okay. All right, guys. Okay. So that's on convex. Now we are not done with the representations yet. Number 4. So representation number 4 we are. Okay. This one is a tricky one because this one is a little bit tricky because okay, give me some time. If this is G bar, right? G bar is the survival function. right? So this is representation 4. Right here, if the marginals of the G distribution are exponentially distributed, that is, you know that the CD 1 minus EF minus X is the CDF of the exponential. I'm sure all of you know that. Yeah? Yeah. So if the marginals are exponentially distributed, then G bar must take this form where A is the same as the one above there, over there. It satisfies the same 4 properties I mentioned a few minutes ago, right? Okay, that's number 4. Now number 5. Number 5 is the following. So this is representation 5. We have covered all. We have covered the Gumbel max domain. We have covered the Frechet max domain. So the only max domain that we have not covered is the Weibel. Is the Weibel max domain, right? Okay. Okay. So in this case, okay. So in the case that if fx and fy belong to the Weibel max domain, there's no known form for G, but it should not be hard to work out a form for G. I mean, if you're interested in, if you want to do a PhD or something, then you can think about how to derive a representation for G when the marginals belong to the Gumbel max domain of interaction. It shouldn't be hard. It's just that nobody has thought about it. It shouldn't be hard. Just nobody has really had time to think over it. It shouldn't be a hard problem. Okay. Okay, guys. So those are the 5 representations I wanted to talk about today. Okay. Now I will do some examples. It's only 4:30 now. I will do some examples now. So starting with some family examples. Let me take an example from the example sheet tomorrow. Okay, so let me take this one. Let me put it here. So I will consider this one here. By the way, this should be G, not F. So this should be G. This is problem 1. Do you have? Everybody has a copy of this? I gave it to you, right? So example 1. Example 1. Okay. So we have G bar equal to exponential of Okay, this is our G bar. Okay. Now the first thing, I mean, we talked about 5 different representations. Which one does this fall under? Huh? We talked about 5 representations, guys. Come on, guys. Talk to me. We talked about 5 representations, right? Now, to figure out which one this falls under, all you have to do is, because x is greater than 0 and y is greater than 0, we just work out G bar at 0 comma y, which is what? If you put x equal to 0, you get exponential of minus y, right? And if you put x comma 0, you get exponential of minus x. Alright, so this implies the following, that the margins of y is 1 minus, and the margin of x, so x is 1 minus. Okay, so this clearly falls under representation number 4. So we need to use representation 4. Okay, now if you look at representation 4, let me go back. This is the representation 4. Okay, we must write this guy here in this form, right? This must be written in this form. So the way to do that is as follows. To write it in this form, guys, you need to pull out minus x plus y. So if you pull out minus x plus y, what do you have inside? You have the following inside. You have theta y squared plus x plus y squared, right? Plus, sorry, not plus, minus theta y divided by x plus y, then plus 1, close bracket. That's it. Okay, this is what you have. You see what I've done? I took x plus y outside over here, right? So this guy here becomes this, right? So now if you look at this form here again, what can you say about a? This implies that a of omega must be theta omega squared minus theta omega plus 1. Do you see what I've done? See, because we need to express G bar, we need to express G bar in this form, right? So to express G bar in this form, you need to pull out x plus y, right? That's what I did over here. I pulled out x plus y. So if you pull this out, inside the curly bracket you have this term, and this term, right? Okay, and what is inside the curly brackets must be a, capital A of y divided by x plus y, which is this function. So our function A, looking at these 3 terms, you can see is theta omega squared minus theta omega plus 1. Okay, is that clear, guys, or no? Yes. Good. Yeah. Are you guys okay? Come on, guys. You're not looking at my lectures or what? Okay, so this is our function. Now what we need to prove is we need to prove that this function satisfies these 4 conditions. Right? Okay, let's do that. So condition A of 0. A of 0 is what? Is theta times 0 squared minus theta times 0 plus 1, which is equal to 1. So therefore it is satisfied. A of 1. A1 is theta times 1 squared minus theta times 1 plus 1, which is also equal to 1. So it is satisfied. Okay, guys? So the first 2 conditions are satisfied. The next condition, is this one here. This one is a little bit tricky to work out. There are basically two different conditions. All right. Let's take the first inequality, which is no. Let's take this inequality first. All right. AW is less than or equal to 1 for all W. Right, which is the same as saying because theta omega squared minus theta omega plus 1 is less than or equal to 1 for all omega. Okay. Now the 1 and the 1 cancels, so this is the same as saying that theta omega squared minus theta omega is less than or equal to 0 for all omega. Right? Now this is the same as saying that theta omega times W is minus 1 is less than or equal to 0 for all omega. Okay. Alright, now this statement is true, which, come on guys, are you guys following me or what? Yes?
Yes.
How about with these guys here? Are you okay? Yeah. Which is true since okay. Alright, so we have proved that this is true, right? Because omega is between 0 and 1, so this must be less than or equal to 0 for all omega, right? The next thing to prove is the following. To prove this inequality, there are basically you have 2 inequalities to prove. The first thing is that you must prove that A of omega is greater than or equal to omega for all W. Right? And then you must prove that A of omega is greater than or equal to 1 minus W. Well, let's prove this one first. This is the same as saying that theta omega squared minus theta omega plus 1 is greater than or equal to omega for all omega. Alright? Okay. Now here you can pull out theta omega, and inside the bracket you have omega minus 1 plus 1 minus omega greater than or equal to 0 for all omega. And then you should take the common factor 1 minus omega, you get 1 minus theta omega. Okay. All right, and this statement is true because if theta is between, the question should say I think the question does not say it, but I think I forgot to say in the question that theta is a number between 0 and 1. So if theta is a number between 0 and 1, then this statement will be true all the time. You follow what I'm saying? And you see that if theta is a number between 0 and 1, this will be true for all omega, right? Okay, and if you don't follow, just let me know, guys, please. The next one we need to prove is the following: we need to prove that a of omega is greater than or equal to 1 minus omega for all omega. To prove this, we do similar calculation. So this will be theta omega squared minus theta omega plus 1 greater than or equal to 1 minus omega for all omega. So the 1 and the 1 cancels, so this will be theta omega squared minus theta omega plus omega greater than or equal to 0 for all omega. Now you should pull out, no, there's nothing to pull out here. You can write this as follows: theta omega squared plus 1 minus theta omega greater than or equal to 0 for all omega. And finally, alright, this statement is true because theta is a number between 0 and 1, so this has to be non-negative, and this is always non-negative because theta is greater than or equal to 0, right? So the whole thing is non-negative, right? Do you see that or not? Hello, guys. Yes? Talk to me. If you can't see that, please tell me. So hence, we have shown hence okay, so hence we have proved that the a of omega is between this and this for all omega. So to prove this statement, to prove this statement, you need to do three things. All right, you need to do three things. First, you need to show that a of omega is less than or equal to 1. Right. Second, you need to show that a of omega is greater than or equal to omega. And third, you need to show that a of omega is greater than or equal to 1 minus omega. So you need to show three things. You need to prove three things to prove this statement. Okay? Alright, guys? So that's what I have done so far. And the next thing, alright, so let's get back to this. So we have proved this one, we have proved this one, we have proved this one. So the last one is that we need to prove there's a convex function. Right? So to prove a convex function, we know that a of omega is, let's write this again, is theta omega squared minus theta omega plus 1. This is your a of omega. Now, so the first derivative, what's the first derivative, guys? Is theta minus theta. Yeah? And the second derivative is 2 theta, which is positive. Hence, So we have proved all 4 properties. Oh yeah. So hence, all right. So that's the concept. So that's how you would do this. Okay. I know it's a long process. Sometimes it can be long. Sometimes may not be long. But oh, sorry, omega. Sorry, I'm being stupid today all the time. And I brought this Tipex for this. Not T, it's omega. Should be omega, not T, guys. Should have told me. Thank you for pointing it out. This should be omega. This should be omega. Okay. Any other questions, guys?
How do you know that theta lies between 0?
Yeah, the question should have said that. I know the question doesn't say it, but in the exam it will say that. In the exam it will the range for theta will be specified. Yeah. Yeah. Any other questions, guys? No? You have a question? You have? No? Oh. Everything clear? Okay, so all right. So let me okay, before the break, let me give you, I've got some gifts for you. I brought some gifts for you today. More than usual gifts. So we'll take a 10 minutes break in a minute. I brought 2 chocolates today. One nice gift. I brought 2 chocolates for you. You guys, no questions? Do you have any questions? No questions? Your friend's still not here. Maybe you can left. Already good. All right, guys. Can I ask you in the can I ask you to stay here? You should and complete the because I checked the unit evaluations and not many people have completed it. So if you haven't done it, can you please complete it now, please? Have you all done it, guys, or not? If you haven't done it, can you please do it now, please? I would really appreciate it. I will because I don't. You can have your privacy because I'm going back to my room now. So in the 10 minutes break, can you please complete the UQ? Thank you. I really appreciate you. Really do it in the 10 minutes. When I come back, I want all of you to finish doing it. Then I come back after the 10 minutes. Thank you.
马上还能给它写上，如果不下如果再下一个读多少分就是
我怎么退不出这个？
你这个用拍的时候还是好
机械飞去了，要不要给你带过来？
好，
没有，还是你。
天呐。我刚就选择报车。
好看的
我还在这儿。我要直接上。
他如果是周六去的话，
哎呀，又过期3天，
啥都没有。我朋友说他们周五去运动7点钟在那个哪里多久
你又去
大花节不是都能那个但是你要大五的话，这个好像挺酷，真的。他好像昨天就是说，周六去的。那个他上面是有几个那个型号的超快，超喜欢那种。
我就服了，它怎么越来越便宜？
就用Fantastic从7.5到7.2到7到15，大概，然后我还把我的200多然后但是以800多来说应该是便宜的。
怎么回事？这么高？
我发现你那个超搞笑，说那个突然才4.1，
先把什么要骚扰你？
路一个山永之巅。还有比心山拉稀。现在了。
找我，微过1个小时。
对呀。
我也知道，我当时也有我那啥，
不是，我有感觉，所以我跟你说了，那30方面，
我刚才买超威的时候，为了凑50磅免邮，我买了双鞋带。
哎，我不能再买了。
我在那儿搜，我就买了双黑色普通的。
我那儿那边有点像那 SC，
我知道了。
超肥它叫。我买2双。
还不了，可是你买的是70的那个。
不一定呀。
对，我觉得70比较适合。
对呀，不一定的，它是没有人的，就是顶多也得是S平方。身上穿那双是很斜的光。
我就买了一双最普通的黑色匡威鞋。我还跟淘宝其实也差不了多少。
我的也好，我的就是你的。谁选你的？你不能吃我的。我刚看的好像不是这个，我刚看的时候没有这些东西。这个好看，我不是很点精致。
出来了。
所有的甜的我也是，所有的都。
但其他老师就不一定。 那老师，但是因为他就在旁边看，所以只能给满分。
好强势。冰箱里放。本来是往冰箱里放。本来就往冰柜里放。
现在就要给发说。
直接封那个。时间污染甲的。
你们都吃了什么？
虽然我们都在家里，我就在家里。但人家凑着热闹。
Only five people. I just checked it. Only 5 people have done it so far.
One of them.
You're only one. Come on. What about you guys? Have you done it? Honestly? Oh, you're still doing it. Ah, come on, guys. I mean, I want to have that all of you. You really could. Have you done it? You have you done the UK? Yeah. You have done it? I don't know. You have questions? What's this question for? You didn't be in the UK thing. You did? I will check in the computer. But you haven't done it. What about you guys? You've done it? Mm. Yeah, please, all of you in this room, please, can you, if you haven't completed the UEQ, can you complete it now, please? All, everybody here. Because when I go back, I can go and check who has done it. Yeah. All right, guys. So let's start again. I've been nice to you guys. Try to be nice to you. Try to be nice to you, to all of you guys. So please complete it today, guys. I mean, before the class ends. All right, I'm gonna do more examples now. So I will start with some. I'm gonna do like maybe 3 or 4 examples today. I know you always complain that I don't do enough examples. So example 2. Example 2 is gonna be it's gonna be like just give me a sec. Well, it's gonna be I from 1 to P should be A. Okay. Okay, this is example 2, right? So this G bar is defined as that, and the question is the question is show that Okay, show that extreme is a bivariate extreme value CDF. So once again, the first thing you must do is to see which of the 5 representations this falls under. Can you see that? Huh? We did 5 representations earlier, right? Come on, guys. Which of the 5 it falls under? To do that, all you have to do is just to check which of the 5 representations. All you have to do is just put y equal to 0. If you put y equal to 0, you will get, what do you get? You will get, it's easy to see, using these properties, it's easy to see that this, right? And we know that AI at 0 is 1, and we know that the sum of alpha is 1, and we know that y is also, this is also 0, right? So this becomes exponential of minus x, right? And similarly, g bar at 0 comma y will be one to p of alpha I. Okay, if x is 0, then AI is 1. Okay, so what you get is AI at 1 is 1, sum of alpha is 1, so this becomes exponential of minus y. Okay, so what you're looking at, you are looking at representation 4. Okay, because both marginals are exponential, right? So we need to use representation 4, right? Okay, so the first thing we need to show, okay, the first thing we must do is to find the a function. Now if you look at this guys here, what is the a function? You can write, okay, from the formula for g bar, right? You can see that the a of omega is equal to the sum from 1 to p of alpha I ai omega. Okay, can you see that, guys? I mean, by looking at the formula for g bar, which is this one here, right? This is the formula for g bar. Can you see that a of omega must be the sum of alpha I ai omega? Can you see that, guys, or not? You guys there? Can you see it? Yes? Okay, good. So what we need to show is that the a of omega satisfies the 4 properties. Alright? So we will start with the first property, which is a of 0. A of 0 is simply and we know that AI at 0 is 1, so this is Okay. Okay, guys. And then A1. Okay. All right. So these two conditions are satisfied. The next condition is that we know that AI of omega, because that's given in the question, that every AI lies between these two limits for all omega, right? So which implies, this implies that if you do the sum, okay, this implies this. Now we know that the sum of alpha I is equal to 1. That's one of the conditions given here. The sum of alpha I is equal to 1. So this becomes satisfied. Okay. Okay, guys. So the first three conditions are satisfied. Now the last condition is that we need to check whether A is a convex function or not. Right? That's easy because the second derivative of A, right, is equal to now we know that each of the, because we are told that AI is a convex function, so that means this guy here is positive for all omega. So this must be positive for all omega. Right? Hence, all four conditions are satisfied. Okay? So, the conclusion is the following. Hence, G or G bar is all right, guys. Any questions on this, guys? No questions? You alright, guys? Yeah? Okay, so that's example 2. Now, we're done with example 2. Another example. Alright, before I do more examples, I would like to go back to what we did last week. Remember, last week I did only 2 examples on I did just 2 examples on the how to find G, right? How to find G. I did 2 examples, right? I like to do more examples if possible today. So let me start by doing few examples. This is stuff we did last week. I know sometimes you say that I don't do enough examples, but I try to do as many examples as possible. So this is example 3. This is based on what we did last week. Right? Suppose right? Do you remember this example? This is we did only 2 examples last week, right? Of this kind. So this is number 3. This is the 3rd example. Do you remember the procedure that we need to follow? There is a 4-step procedure we need to follow, right? What's the first step? Do you remember the first step? Come on, guys. You remember the first step? Marginal CDF, right? Okay, so the marginal CDF is gonna be, we know that f bar at x comma 0 is 1 plus ax minus k. So that implies that okay, and we also know that f bar at 0 comma y is 1 plus, so this implies that okay. Alright guys, so that's done. Right, then that's step number 1. Step number 2. Step number 2, do you guys remember what it is? Is to find the max domain, right? To find the max domain of the marginal CDFs. What do you think the max domain will be? You should have experience. You think it will be Gumpel or Fresher or Weibel? Fresher, yeah. I mean, because by looking, I mean, in the exam, you don't want to waste time like checking all 3 conditions, you know. Sometimes you should done enough examples, you should know like which conditions will be satisfied. You know what I'm saying? If you've done enough examples, you will have a feeling about which of the 3 conditions is going to be satisfied. I mean, I know, like looking at a CDF, I can tell which will be satisfied. Like in this case, I think this condition 2. Clearly, you can check this plus infinity. You can check w of fy is also plus infinity. I'm not going to do it. You know how to do it, right? Okay. So I'm going to check condition 2, which is limit okay, this is condition 2 for fresh limit. Okay, so this will be limit. Now what would this, okay, we know this is the CDF, right? So if you put it here, guys, you get 1 plus a okay. Now how do you find the limit of this, guys? Okay. Now, what I'm going to do is I'm going to divide the top and the bottom by t. Alright, so you get 1 over t plus ax divided by 1 over t plus a. Okay. Alright, now we know that, where's my pen? We know that this guy here goes to 0, this guy here goes to 0, so the limit is x to the power minus q. So hence okay, hence fx belongs to the pressure in my stomach. So I mean, so our guess was correct, you know. And as I said, you should done enough examples on this. I mean, I gave you several quizzes on this, so you should have some experience. You should be able to look at the CDF and tell and guess what the domain of attraction is going to be. Now, similarly, okay, similarly, Fi also belongs to the same max domain of attraction. Okay, guys. So now the next thing to do, let me put it here. Step number 3 is to determine the A and B and C and D, right? This is where this is where our things comes in. So step number 3 okay, our AN is remember, if you look at the formulas I gave you, the formula for an is the inverse function of the CDF of x at 1 minus 1 over m. So to define that, you need to set the CDF of x, which is, this is the CDF of x, right? So to find this, you need to set 1 minus 1 plus ax to the power minus q equal to 1 minus 1 over m, and solve this equation for x. That will be your an, right? So this implies that okay, and this implies that 1 plus ax is equal to 1 over n 1 over q, right, which is n to the power 1 over q. Okay, so x is equal to n to the power 1 over q minus 1 divided by a. Right, so your an is equal to n to the power 1 over q minus 1 divided by a. And your bn is 0, and your cn can be determined similarly using the same idea. Your cn will be this, and your dn is also 0. So I'm just using the formulas that I gave you last week. Remember, for Froschet domain, the bn and the dn are 0. So only an is fx inverse and cn is fy inverse, right? Okay. All right, guys. Any questions so far? The next one, the last step is step number 4. Is to find the limit as n goes to infinity of f to the power n. Okay. Now, how do we find the f here? Any ideas? Because what you're given, you should go back to the question, guys. What we are given is f bar, right? Not f. So you remember a long time ago that I gave you a formula on how to. Long time ago, I showed you how to go from f to f bar and f bar to f. Do you remember that or not? Come on, guys. You forgot or what? Long time ago, I gave you a formula on how to go from this is like this. Okay, what you need to do is this. Do you remember this formula that if you have a joint CD of f, it can be expressed in terms of, oh, did I do it right? Well, this is f. Maybe not right. But let me see. F in terms of do you have the notes with you? Is this right or not? Or is it wrong? Do you guys have? I don't.
No, it's 1 minus fx bar.
Huh?
Fx bar and fy bar.
There should be a bar here.
Yeah.
Okay. Now it's okay. Okay, thank you. So there should be, yeah. Thank you. I mean, I'm an old man. I tend to forget things. You guys are young. So fx bar, we know is this guy here. So it's 1 plus, is it a? Yeah, ax. So it's gonna be 1 plus a times n x plus bn power minus q, 1 plus b times cn y plus dn minus q, then plus f bar we know is this guy here, is 1 plus alright, I know it's a nasty expression. This is what you get. I know that bn is 0, dn is 0, and we know the formula for an, and we know the formula for bn, cn, right? So hopefully things will simplify. Let's see how things simplify. So this becomes bn is 0, so this is, should replace an by that. We get a will cancel, so you get 1 plus n, a will cancel, so times x to the power minus q, right? Then minus 1 plus and then you have this plus statement, which is gonna be nasty. It's gonna be plus 1 plus in and then in cn, which is it's gonna be c divided by ab times square x y. Okay. So the whole thing power minus q, and the whole thing power n. Okay. I know it's still a pretty nasty expression. It's still a nasty expression. Okay. Are you guys following me? Yeah, so it's gonna. So you have to be really good in your limiting calculus to do this kind of calculations, but it's not. I mean, all right. Let me put it here. Let me put it here. The next one is all right. The next one is I'm gonna pull out these two outside the brackets, and similarly here over here. So it's gonna be 1. So the limit as n goes to infinity of 1 minus 1 over n times hello, somebody this is what you get, and then the next term will be 1 over n times and the next term is going to be plus 1 over n then over here it's going to be tricky where n and this is dividing by that, so it's going to be plus this whole thing in power q, this whole thing in power n. I know it looks pretty nasty, I know, but you know these are kind of calculations. Sometimes they can look pretty, but after a while things will simplify a lot. You know, let me show you. This term, this term, this term, all the terms I've circled in red. Can you see all the terms that I have circled in red? As n goes to infinity, they will go to 0, right? Each of the terms that I have circled in red will go to 0, right? So this goes to 0, 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 this goes to 0. So what you have left is the following. You have simplified a lot. You have 1 minus 1 over n times x to the power minus q minus 1 over n times y to the power minus q, and then over here you have this is 0, so you have x plus y plus 1 over n times x plus y plus cxy divided by ab times n cubed minus 1 to the power minus q to the power n. Right? Okay. Now at this stage you need to use the familiar rule. I don't know what I hope the familiar rule is that you can write this as the limit of 1 minus z or z divided by n to the power n as n goes to infinity, right? Where your z is equal to this. Okay. All right, this is your z. Right. Now we know that this guy here, the limit of this is okay, but z itself depends on n, right? So to finish things up, what you have is the following. You have this is the same as the limit as n goes to infinity of e minus plus okay. Now we know that as n goes to infinity, this whole thing here goes to infinity, right? As n goes to infinity, so infinity to the power negative number is 0. So this becomes e of minus x to the power minus q minus y to the power minus q, and this is your g of x comma y. I know the calculations are long, but basically you need to use the limiting calculus. I'm sure if you have forgotten your calculus, if you've done a few examples like this, then you will get used to it. Tomorrow also, when I meet you guys, I will do a few more examples like this tomorrow. Okay. Any questions you have? Yes. Any questions, guys? So as I said, we will finish the syllabus this week. Next week we will do a revision. So any questions you guys have next week, you can bring it. You can email it to me, or you can Zoom me, or you can come and see me in person. Right? All right, guys. How you said? All right. Everything okay? All right. Finally, if you haven't completed the UEQ, can you do so now, please? Because when I go to office, I will know who hasn't completed it. So if you haven't completed it, then you will get an email from me. That should say. Yeah. Thank you, guys. All right, guys. Yes. Can I have that cover sheet back? Yes. When? Okay.
Yes.
因为它这个题变少了，我的分儿就好了。
Alright guys, see you tomorrow. If you have any questions, come and see me, okay? Or email me, or Zoom me.
Yeah.
Hi.
I got a few questions.
What? Hey.
Yeah, I guess it should be 1 over q the power.
Is it?
Yeah, because this is a square term and it's just 1 over m, and so the rest of the part should be. Can I check your?
Oh, okay, let me check. I think I might have made a mistake. Just a minute. What is it? I see. Okay. Okay. Is it this one?
Yeah.
There are two terms here, yeah.
There are 2 terms.
One of them goes to 0. This one goes to 0.
The previous thing.
The previous.
Yeah, this is a square term.
It is a square, yeah.
Yeah,
There's a square here.
And it takes, or it takes
There's a square here.
yeah.
Yeah. So which one are you?
So the next step is the next step.
The next term.
You take 1 over n outside.
Yeah, I took 1 over n outside.
So
So that means
so
so that means one of these terms.
yeah.
One of these terms becomes this. The other one remains like this.
Why don't we remain the other side?
Because it's nq minus 1. Okay, let me write it down. Do you have a pen? There's a pen here. Do you have a paper? I can. Okay, let me get I have a paper here. Just a minute. Wait a minute. I've got to find the paper. Okay, because it's like this. Because you have 2 terms here.
Yeah.
Yeah. When you take the 1 over. When you take 1 over n outside, okay, it becomes like this. You are dividing. You are taking 1 over n outside, so that means you are dividing squared divided by nq. You are dividing by this term.
Yeah.
All right.
Yes.
So this is the same as saying that. Well, no, I think I made a mistake. Well, I might have made a mistake, but I don't think it will change.
It won't change the result.
Yeah, it's the same as saying this, right? And this is the same as saying that this is 1 minus n minus 1 to the cube.
Yeah.
This is n to the power 1 over cube minus 1. So this should be, I think this is correct, but except there should be 1 over cube here.
Yeah, 1 over q.
It should be 1 over cube.
Yeah.
So this should be 1 over cube, and the rest, I think the rest are correct. I think So this this is
the
it
one
should
change.
also be 1 over q. So this is okay. Yeah, the rest is okay. Okay. So you can have this if you like.
Thank you.
Thank you for pointing that out. You have a question, sir? You